Okay, let's get started. So we were going over this function thing last time, and I mentioned that for this solution to assignment 3, there was a lot of repeated code, so we can actually hoist a lot of it out into a function to make it a lot easier. So I didn't complete it last time, but I'm just going to go over a completed version. So this function right here, I said I'm going to design it in such a way that it returns the price, and it will change the reference variable item count back in the main function. So remember, the main function for this assignment will have the number of the item as well as the price of the item. So the reason I want to reference here is I want to affect that variable back in main. But I can just return the price if I wanted to. So, so that's what I do. So I print how many of the item, so now it'll change depending on what string I pass in. I probably should get rid of burgers here. Yeah, I don't want shake burgers. So how many of those you want to order? I see in the item count just like before. Then I do a check here. There's something wrong with the check, which we'll get back to in a bit. So we handle the check, and then at the end, I just return the price, the item count, and then the third argument of this function is the price per item, namely the ones out here. And I'll explain why they're out there when we get to global variables. So basically, all that code about inputting just reduces to this. We just iterate through all the items. So we look at, say, double doubles. Then I pass in the number of double double variable that I want to be affected to have the number that's ordered, as well as the price of one double double burger. And then the same with all of the other items on the menu. So I'm going to ask you two questions. So from the original program, for all of this input code, for the original one without the extra function, how many lines was it to input these items? Can you take a guess? 80, any others? It was actually right around 90 lines of code. So now we've reduced it to around 11 lines of code plus this function. So what do you think is better, the original one or this one? This one is much better because now if I need to change one bit of logic for one of the items, if I just change it in the function, I've affected all the items simultaneously. So the other question, and now I forget it. Does anyone see any problem with this error checking right here? What do you think this return 0 does? What did it do back in main? It stopped the main function and then the program quit. What does return 0 in the function, not main, do? It returns 0. So if I input something bad for, say, hamburger, then HB cost is going to have the value 0 because it returns 0. So then we're going to continue with the rest of the code, and that's not what we want to do. So we'll see something about how to stop the program from a different function, not just main. Okay? But any questions on why we did it this way? Why this is much better? So yeah, that's why functions are so useful, so that we can hoist all of the repeated code or maybe a small change into a different function so that I don't have to repeat myself. Okay? Any questions about it? Yeah. So return here, so remember, handle item is being set to a variable, which is the total cost of all of that one item. Yeah, so of course there are many, many ways I could have done this. I could have declared a whole bunch of doubles here as well for all the costs, made this a reference variable, and then just set the cost accordingly. But it might be a little bit more tricky in that case. So there are many ways I could have approached this. But any other questions about this? Okay, so we have a lot to get to today. All right, so I mentioned last time, how do we pass data into a function? And there are two ways. One was by value, and the other one was? By reference, good. So by value copies the value of the variable into a brand new variable. So it's two independent copies. For reference, you don't do an additional copy of that variable, you use the original one. Okay? So there are use cases for which one you should use. Sometimes you do want to modify the original variable, like the example I just gave, or you do want a completely independent copy. So yeah, a reference variable for really anywhere, but we're mainly using it for a function now, is where you put the ampersand right after the type. So instead of saying int some variable name, you say int ref the variable name. Okay? It doesn't have to be sandwiched to the int. You could put a space if you want to, but it appears right after the type. So if you want a reference to a double, you say double ref the variable name now. Okay, yeah. It's mainly used to implement passing parameters by reference. So here is an example. Remember, a prototype is just everything about a function except for the body of the function and with a semicolon after it. I'm declaring this function to exist. And then now I'm implementing the function. So this function, does it return anything? No, and how can you tell? It has the void return type. Okay, so void means don't return anything. The function's called squareIt, and it's taking a reference integer called num. So what we're doing here is we're modifying the original variable. So we're modifying the original variable by, what are we doing in this function? So what is the times equals short for? Yeah, so all we're doing really here is multiplying num by itself, i.e. Squaring the number. So if we have a local variable here, so these two lines are in the main function or some other function. So we say local variable is equal to 5, and then if we call squareIt on this local variable, now we're modifying the original variable, local variable. So now local variable has the value 25, okay? So I'm not returning from the function. If I got rid of that ampersand and I just made it a normal pass by value parameter, at this point, what will be the value of local variable? Yeah, 5, because I'm not modifying the original variable, I'm modifying a copy of it. So when this function exits its scope, this brand new copy goes away because it's not in the scope anymore. So when I come back to this call right here, local variable has not been changed, so it still has the value 5. So you may want to have reference on some variables, you may not want to on some other ones. Yeah, so if you want a reference, you have to have the ampersand. It must be a variable. Why? What if I just called squareIt of 5 in the parentheses? What would happen there? Well, can I modify a literal? No, I can't modify a literal. I can modify a variable, but I can't modify a literal. So that's why it must be a variable if you're using a reference. Yeah, it can't be an expression or a constant. Yeah, only when it's really useful. It says files, of which we haven't really covered yet, but suppose we have a way of interfacing with a file, for example, should be passed by reference. Anyone know why? Well, well, it may be okay if we, for example, let's say we're reading from a file, and I don't want to modify the original file. So what should I do? Should I pass by value or by reference? I don't want to modify the original file. Value, right, because I'm making an independent copy. But why would I want a pass by reference? Of course, if I want to modify the file, of course I use pass by reference. But why else might I want to use pass by reference? What if the file was huge? Do I want to make a completely independent copy? It's not a rhetorical question. No, because then I'll be using a lot more memory than I need to. So pass by reference is mainly used if we have some structure that uses a lot of memory. So for example, in your assignment 4, for all the cases, suppose we stored all the cases into a file, for instance. Do I want to make an independent copy of that file? Probably not. So that's why it says should be passed by reference. And when we get to objects and classes, and as well as arrays, this will be even more apparent. But yeah, so for things that are big, you should pass by reference if you can. For small things like integers, it effectively does the same amount of memory allocation anyway, so it doesn't really matter. But for large things, like for files, a lot of data, then you want to do it by reference instead of by value. Sometimes for functions, if we don't initialize a parameter, maybe we want to set it to some default value. So for instance, this allows us to have multiple ways of calling the same function. So for example, this getSum variable. So what does this do? It says we can either take 1, 2, or 3 parameters to this function. So these second and third parameters are optional. They're not required. But if we don't put something there, then the default is 0. So for instance, if I called getSum of 5, what should the function return? 5, because it's adding 5 default 0, default 0. But suppose I call it with getSum of 5 and 2, and I don't put a third parameter. What should it return? 7, because I'm adding 5. Now I'm overriding the default value, which is 2, but I haven't specified the third one, and so its default value is 0. So the main point of having default arguments is that I can call this function in multiple ways with multiple parameters, and if I don't happen to give it some parameter, then the function will still carry through with a default value. So, but an interesting question might be, well, what if I wanted to call getSum with 4 parameters, or 5, or 6, as many parameters as I want? That might be useful, but what is the number of parameters I'm maximized to allow to use to call getSum? What is the maximum number of parameters I can use for this getSum? 3. I can't call it with 4 parameters. So you may think, well, how can I do any number of parameters? And we'll talk about that kind of thing in a month, which is something called templates. Actually, they're called variadic templates, but templates we'll talk about later. But for default arguments is when you have a fixed upper bound on the number of arguments you need. So if you need 3 or fewer parameters, default arguments are a good way to go. So yes, here's some guidelines. I probably won't ask about this on a test or in an assignment, but it's just good to know if you need default arguments or see them in the wild somewhere. Okay, so there are 2 types of variables, though, that we could use in functions or may not use in functions. So a local variable is just one that exists within some scope, okay? Usually within a function or a block of code. So for example, any variable you declare in the main function or in the function we made in that one example, those are local variables. If you declare a variable in a for loop, while loop, if statement, or else for that matter, those are also called local variables because they're within some scope. Yeah, so if you declare a local variable, you can't access that local variable outside of its scope, as you already know. So they're created when a function begins. Is that true? They're created when the function begins? That's actually not true. Why is it not true? They're created when they're declared, right? So they're created when the function, when it finally reaches the line for which it's declared. But it is destroyed when the scope terminates. So it's not the function here, it's the scope of where the variable exists. So if I declare a variable somewhere in an if statement, for example, say I declare it here, it'll be allowed to be used anywhere until the closing curly brace of the if statement. So when the if statement is done, then I can't access that variable anymore. Yeah. So same thing with functions. If I declare a variable in a function, when the function exits or returns or whatever, then that variable is destroyed. So, but the difference here is something called a global variable. So it's a variable that is declared outside of every scope, meaning that it can be used in any scope. So I can show you an example. If you look carefully, you can actually see this in action. So all of these variables, these constants, I declared outside of all scopes. So it's not inside a main function, and it's not in this handle item function. Meaning, what are they called? Are they local or global? Global, good. So a global variable then is something that I think should be used in every part of the program. Well, if something would do a tax rate or the prices or the error string, I think those are potential uses for a global variable because it seems likely that I'm going to be using those variables all throughout the program. If I, for example, let's see, what would be an example? So like for the special order stuff, when I see in this new order string, should that be a global variable? Would that make sense? So no, because what does it make sense here? It makes sense to have this new order string be declared whenever I'm going to order something from the secret menu. So it should only exist within this scope. So therefore, it should not be a global variable. Could I make it a global variable, though? Would it be wrong if I did? No, there's nothing wrong with putting more scope into a variable. It might not work if I put it into say, in this scope down here. It may not work there. But if I put it into global scope, it'll never be wrong. Yeah. On this if, it's way down here. Yeah.
Well, why would you run from more scope already big enough scope? Wouldn't you run into counterintuitive?
Right, it's counterintuitive, right? And it's actually a bad idea, and for reasons I'll get to in a second. But so determining what should be a global variable and what shouldn't be is actually a delicate art, because now you have to think, well, anyone who uses this program has access to this global variable now. And so now I have to think, well, what should be global and what shouldn't be? And remember the idea of compartmentalizing your thinking. So if I put this variable into global scope, now the issue is now I could put anything in the global scope, and then now I have to think every variable is now in global scope, which doesn't really make much sense. So now I have to, so I think it's a good idea to put new order in this local scope. But let's go back to here. It says that, of course, when you have a global variable, it's from when it's declared to the end of the file, it could be used. But it says use sparingly. Why? going back to your question, why should we use global variables sparingly? Yeah.
There's, like I said, if you want to count here, you're going to equalize this, but then later on you're going to set that variable to another thing. Like, what?
Right. So now anyone can access this variable and change it. Yeah.
Does it make debugging difficult?
It makes debugging difficult. Yeah.
So would the best variables you were like constant variables?
Exactly. So the best contenders for a global variable are constants, because what is the meaning of a constant? It can't be changed. So if it can't be changed, then do I have any problem putting it at global scope? No, because it can't be changed. So therefore, I don't have this issue of debugging or anything like that. But even with constants, it still may not make sense to put it at global scope because you may only want it at some local scope. So just use them sparingly, and you should only really use them for constants. Yeah, so local variables have to be initialized. So remember, maybe on a test or a quiz, I forget where I said that it was a true-false question, so on a quiz 1, I think, where I said that it was false that some variables are initialized to 0 and some are not. This is actually the difference. So local variables may or may not have a default value 0, say, let's say an integer. But global variables, let's say for int, are automatically initialized to 0 for reasons that are kind of complicated to explain. But the main reason is that it doesn't incur any runtime cost, because if we have the main function, if we default initialize the values that are not in the main function, then the runtime part of it is in the main function, but they're already default initialized. So that's why global variables are default initialized to 0, or don't worry about this null thing, but default initialized to 0. Programs that are difficult to debug for global variables, that's true. Functions that cannot easily be reused in other programs. They're not really clear on what that means. Oh, they make functions that cannot easily be reused, yeah. So if you have a function that uses a global variable and you put it into some other code, and if you don't do the right includes, you may not have this function be able to work. So if you have things all in the same scope, it should be much easier to work with. And it's hard to understand because now you have to think, okay, this variable is global and this one's local, and now we have to think about that sort of thing. Global constant is exactly what we've been talking about. Yeah, so it's exactly what I said. But there's something different here. We have local variables, we're all familiar with that, but there's something called static. So static here is, for example, if we're calling a function over and over and over, if we had a normal local variable in this function, then every time we call this function, that variable will be initialized to a new memory location. So it's a brand new variable every single time we call this function. But if we had a static local variable, then there's exactly one piece of memory dedicated to that memory location. So for instance, if we had in this handle item function, so let's just say we wanted to know how many times we've called this function, okay? So let's say we wanted to know the number of times we called this function. Well, since it's a local variable, I have to initialize it, let's say to 0. So if we call this function, if we want to know how many times we've called it, let's say we wanted to add 1 to this count. But the issue here is, if I call handle item over and over and over, then count is going to stay at 0 when it gets in the beginning. It adds 1. But anytime I call it again, it'll be reinitialized to 0 and then add 1. But if we have static here, then the first time we call this, it starts off at 0, adds 1. But the next time we call it, it'll still have the value 1 because there's exactly one copy of this variable. And then it'll be incremented to 2. Next time we call it, it will have the value 2, increment to 3. Mm-hmm. No, a good question. So the question was, if we did this, if we called handle item over and over, would count still have the memory location there? And the answer is no. So for reasons that are kind of complicated to explain, handle item allocates memory enough to hold all of these variables every time you call it. And then when handle item goes out of scope, it deallocates all of that memory. But if we had a static variable here, this count now is initialized somewhere else, not in this where handle item allocates it. So when handle item deallocates all the memory it needs, then this variable is not deallocated. So that's what static is for. So static variables are good for, say, knowing how many times you called a function or maintaining some kind of sum, that sort of thing. I haven't used it that much, but it's good for that type of purpose. If you want to know, let's say if you're debugging a program and you want to know how many times a function is called, static is a great way to use that. Okay, but is there a way that I can get around using static? Let's say I hate static. I hate static electricity. I hate the word static entirely. Could I get around this? Use a global variable. So instead, what I could do is this. So I make a non-constant variable on the outside, and then I don't know why this is having an issue. Let's say we do this. Okay, there must be some other variable called count. I don't know what. But so let's say I have a variable here called count2, and then I add 1 every time. Then static is effectively making a variable global. But the good thing of static is that it only exists within the scope that it's defined. But for a global variable here, now it can be accessed anywhere. So there's sometimes when you want to use static, sometimes you want to use global. Okay. Any questions about static? Hopefully not electricity because I'm not a physicist. Yeah. It's exactly the same amount of memory. It's just the way you access the variable is going to change. Because static is only able to be used within the same scope that it's defined. So in that function, I can only still use it in that function, but it exists throughout multiple calls of that function. Global can be used everywhere. So sometimes you want to use one, sometimes you want to use the other, depending on how you want to access the variable. Other questions? Okay, so sometimes you want to have multiple functions that are called the same thing. So for example, recall the min function, where you take it takes 2 parameters and it returns the minimum of them to you. Well, we haven't gotten to templates which solve this problem, but suppose we ignore that. Suppose we want to have a min function where it takes 2 integers and another version of the min function which takes 2 doubles. And maybe we want to do some different work in the double version and not in the int version. So that's what's called overloading functions. So here, overloaded functions means it has the same return type, same name of the function, but the parameters are different. Okay, so the parameters have different types, or there are a different number of parameters. So I can show you examples. So let's look at these first 4. The first one is an overloaded version of the second because they have a different number of parameters. So the compiler thinks of them as different functions. The second and the third are different because the types are not all the same. The first argument type is int in both cases, but the second one is different. So the first one is int, second one is float. So Yeah. So now, if you have an int in the first position and an int in the second position, then it knows for sure to call the second function and not the third. Because if you have what is called an ambiguous call, you may have a situation where you want to call this, the compiler may want to call this function or this one, but it can't decide which one you actually meant to call. So if you have completely different types here, then you're guaranteed to not have any problems. And then the first is different from the second because they're different types again. So, and we can call them in the usual way. So if you have a different number of arguments, there's no issue. But if you have the same arguments, you may have some issue if the types are the same being passed into them for the two functions that you're dealing with. So overloading, all it means is that you have the same return type, the same function name, but the parameter types, either in number or in the type themselves, are different. Okay? Any questions about overloading? Yeah.
Why, when you enter length and height, even though height is double, does it then
Yeah. I was confused about that too. Yeah. Oh, I think it's because float and double are what are called implicitly convertible to each other. So I can convert a float to a double, maybe not precisely, but I can convert one to the other. But I can't I can convert an int to a float or double, but I can't necessarily convert a float or double to an int without explicitly saying it's an int by doing what is called casting. So that's why there are actually different types. Yeah.
I was talking in the third example, when you call float, it pulls height instead of base.
So you mean down here? So it's calling the third function. So it's because length is an integer and height is a double float, same thing. So it can't call the first function, no issue there. Can't call the second function because it can't convert an int or a float or double to an int without explicitly saying so. So it can't call the second function. So what actually happens here is it looks from top to bottom and then finds the first example for which it works. So the third example works. Fourth example, I think, works too, because you can always convert an int to a double. So yeah, I think it's because it looks from top to bottom and finds the first one for which it works. Other questions? Okay, and then one more slide before we get into objects. You had a question? Okay. So the issue that we saw with the example I had earlier, let's get rid of this count to business, is this return 0 thing. Because if we return 0, then that's not exactly what we want. We want the program to stop. We don't want to return 0 and have the main function continue from then on. So there's a function called exit. So exit allows us to immediately quit the program right from when it's called. So the parameter passed here is the same thing that you would do if you want to return from main. So for example, if you want to return 0 from main, you'd call exit 0. So you're never wrong if you want to immediately quit the program by saying exit 0. Exit 1 is used if you want to return a non-zero value from main. It does the exact same thing. But here, exit 0 is perfectly okay to use. It just means quit the program immediately from here. I don't care what's happening. Stop the program. Okay. And then, of course, you have to use some other header file. Sometimes you might not if it's already included. Yeah. So it does exactly the same thing as returning from main. It's just now called exit. If you want to use it not from main, yeah. Because if you're using it from a different function, return 0 has a different meaning in the function point of view than doing exit 0. Because if I return 0 from a function that's not main, then main might receive that value that's returned, and then it'll continue from main and not stop the program. So exit 0 is the best way to do it, and not using return 0. Okay, and then, so there are constants in the header file called exit success, exit failure. They're just constants to make it more clear what you mean if you call exit of something. Nothing special there. Any questions about exit? Yeah.
So does that mean if you never return 0 inside main, it'll always end the whole thing?
Yeah, so returning from main will do the exact same thing as exit, but it's just if you're somewhere else, then you actually do need to call exit, because return 0 there might return the value and not actually stop the program. Other questions? Yeah.
So let's say we're using like
Mm-hmm.
the error codes, right? How do I view what
Yeah. So I think you can actually see. So if we just be dumb and say exit 1 right at the beginning of this code, then it should say process finished with exit code 1. So that could be an indicator for you. There are myriads of other ways of debugging code to see like what's actually happening at a particular moment. Yeah, I think this is okay. For your purposes, if you want to debug, the best method I know for introductory programmers is to actually print something. So like, if you want to know what the value of a variable is at a certain point, just say cout the value of this variable is this, and then you can actually see, if you just run the program, to see how your program's actually running without having to step through it yourself. Other questions about functions or exit? It's when you want, it's this example. If we input something that's wrong, we want to immediately exit. I can't return 0 here, because then main will receive the value 0 for a variable, then main will continue. So I have to put exit 0 here. So it's mainly when you want to stop the program from not a function that's not main. So if you're not in main and you want to stop the program, use exit. If you return 0, that might do something else. Okay, let's get on to objects. And you have a quiz that I'm going to give to you at the end, so remind me at the end. Okay, so what we've seen so far is the if and else statements, for loops, and now functions. But what we were doing with say the menu application, we had to keep track of all these variables, right? And so we had to declare a whole load of variables, and we had to initialize them, we had to work with them, we had to input for every single one, although functions help with that, but we still have to declare them and all that. Well, what if we wanted to do the exact same type of idea, but for all ASU students? So I wanted to keep track of the name of a student, the GPA of the student ID number, emergency contacts, all of that information. Could I, in principle, make variables for every single ASU student? Could I do that, in principle? But would it be a pain to do? Yes. So that's where objects are going to help us here. So what objects do is nothing that we couldn't do before, but now we can package a whole lot of data into one object. Okay, so instead of saying like the cost of double burgers, as well as how many that are ordered, as well as the name of the item, now we can package all three of those items into one piece of memory. Okay, so that's what objects get for us. So an abstract data type, so all of the types that we've seen are provided by the C++ language, Yeah, it's provided by the language. But now what we're going to do is we're going to make our own types. Okay? So instead of working with a string, for example, we'll work with a type that we call, for example, ASU student. Okay? So then we can say, well, what types of ways that we can work with this new type that we're making. So an abstract data type is just an abstract way of holding a lot of data and defining what you can do with it. Okay? So for instance, an abstract data type, say for an integer, would be what things can you store in an integer? Well, a whole load of bits. And how can you operate with multiple integers at the same time? Well, you can add them, subtract, multiply, divide. You can do a whole lot of things with that. But if we want to have an ASU student, well, what are the things that we want to know to keep data on? Well, the name of the student, the GPA of the student ID number. So those are the things we may want to keep as data for the student. But what are the ways we want to operate on this one student? Well, we want to, for instance, update the GPA of the student, or update the emergency contacts, or in some cases, update the name of the student, right? So we got to define the ways that we can access or interface with the data that we're storing in this abstract data type. Okay, so the whole point of objects are to abstract the data away. Okay, so again, it's like functions in that we're compartmentalizing our thinking. So the way that we're going to look at this is this abstract data type is going to have all this data right here. And so now we have two ways of thinking. Well, we could be inside this abstract data type and be thinking, how do these pieces of data relate to each other? And how do we operate on the data here? But the other perspective is, we're looking at this data type from the outside. We don't see what's happening on the inside, but we just see the student as a whole. And we say, oh, I want to update the GPA of the student, and I'm going to forward the work onto this data type, and I'm going to let it do the work for me. I'm not going to think about what's happening on the inside. So for instance, like all of the functions that we've been using, it's like the PAL function. Do you know how the PAL function works? Do you care? No. So you're viewing the PAL function from the outside, and you're saying, oh, whatever happens on the PAL functions on the inside, I do not care. I just want the result of this number raised to that number. Same idea here, but we're going to define our own data types that way. So abstraction is just don't care about the details, just get the general behavior there. Data type is just what we've been saying. It's the values that can be stored as well as what you can do with the values there. So this slide was from the very first set of slides, but it's useful to go over again. So C++ is a kind of a dual language. It is what is called procedural, meaning that we go from the top of some function and then continue down to the bottom. That's the way we've been programming so far. So we start at the top of a function, maybe we call now another function, but we start at the top and we work our way down as specified. But another method of thinking is we work with these abstract data types or objects, same terminology. So we work with these objects and they hold data and we interface with them directly. So the object now is not procedural. We're not starting at the top of something and working our way down. We're working with data one at a time or multiple at a time. So just some terminology. So the object is the entity that holds all the data. Okay, so in a single unit. So the data inside the object are called attributes or member variables. Okay, so I'll probably just use attributes for this, but member variables means the same thing. But in order to do anything useful on the member variables or attributes, we have to have member functions. So they're usually called methods. In some other languages, they're called methods. But we need some way of operating on the data there. Data hiding, so remember the two perspectives we had. We can work with the individual pieces of data inside the object, or we can view it from the outside and say, I'm not going to think about what's happening on the inside. So data hiding is when you are restricting access to the attributes of the object. So for instance, suppose we're making a bank account. And one of the important pieces of data that a bank account might have is the balance on the bank account. Should I make that visible to the outside of being able to modify it? No, because I can just say, oh, I'm going to add $1 million to my account. And if I did, I wouldn't be here. But that would be an example of data hiding. I'm hiding the data that I don't want modified explicitly from the outside. If I wanted that to happen, then I actually could. But the principle here is that we're hiding the data that's not necessary to expose to the outside. Encapsulation is the process of doing this. So it's hiding the data but putting it into a single entity. So let's see. So here's an example of an object. So I'll tell you what this notation means. We haven't gotten to that yet. But say we're modeling a square for our Insanely Great Shapes company. The piece of data for a square, all we really need to know is the side length. Do we need to know anything else about a square to know all the properties of a square? Not a rhetorical question. No. So if we had a rectangle, then we need to know the length and the height. But for a square, we only need to know one piece of data. So thinking about the object in terms of what variables you actually need and variables you don't need, that's an important thing to be able to do. But what we're doing here is the member variable, we have one variable there, which is the side length. But of course, if we want to change the side length, maybe we want a bigger square, we could avoid data hiding and say, yeah, we can allow you to change the side length arbitrarily. And we can see how to do that. But the way of encapsulation and data hiding says is we're going to make some functions on the square object. And we can say, oh, through this set side function is the only way you can change the side of the internal variable. So we're hiding the variable away from the user, but we're saying, I'm going to provide you this interface which allows you to not only retrieve the value of the side variable, but also set it accordingly. Okay? So that would be something for like a bank account. Should I have set bank account balance as exposed to the user? Should I allow them to set the bank account balance? No. But should I allow them to get the balance? Yes. So thinking about what set functions you should have and what get functions you should have is actually pretty important. Yeah, so why should we hide the data? Provides a layer of protection. But another reason is that it makes the effort on the programmer that's using this object a lot easier. Because now all they have to think about are these two functions, right? Instead of thinking, well, how can I access this variable side? All I need to know is, what are these functions, right? If I had other functions, all I need to know are those. I don't need to know what's happening on the inside. Do you need to know what's happening on the inside of a string variable? No. Well, what if you wanted to get the fifth character of a string? Well, there's a way to do that. But do you interface directly with the inside of a string? No. You interface with the what is exposed to you from the string object. So there's a protection and a need to know type of thing. Any questions so far on objects? Yeah. No, so that's completely different. It just means we're not returning anything. If I'm setting a variable, there's no need to return it. I could return something, but I don't have to. Any other questions?